All right, what's going on, everybody? Today we're doing another LeetCode problem. This one's called longest repeating character replacement. Um, it is a medium, and we're going to be solving it in C++. So let's get into it. So we're given a string s and an integer k, and we can choose any character of the string and change it to any other uppercase English character. We can perform this operation at most k times, and they want us to return the length of the longest substring containing the same letter you can get after performing the above operations. So looking at input output, so like, what does this mean in English? It's a little like I don't really understand that at first personally, but I think looking at input and output helps a lot for problem statements that are a little bit involved like this. So we have two input parameters here. We have a string s and then we have an integer k. Note that our string s is going to be at least going to have at least one character. It's only going to have uppercase English letters, so we can really think about this and optimizations for the data structures we're using. And then k is going to be between 0 and the length of the string inclusive. So basically, if we had the string AB and k equals 2, that means we can replace up to 2 characters in the string and then after we do that, after replacing we want to replace 2 characters in the ideal way to give us the longest possible substring that is just all the same letter over and over again. So like, if k is 2, that means we're allowed to replace up to 2 characters here. So if we replace the b and this b, we would just have a string of all a's, and that would be length 4. Also, you could do the inverse of that and replace the a's with b's, and then you just have a string of b's here. But nevertheless, it's going to have the longest substring of the same character there after doing our replacements is going to be 4. For this, for example, 2, notice that we can only replace 1 character. So like, we can't replace this b and this b and this b and then have a substring of length, let's see, what is that, like 7? We are not allowed to do that. We can only replace 1 character. So the longest substring containing the same character we can get would be 4, because you could either replace this b with an a and have this substring of length 4, or you could replace this a with a b and have this substring of length 4, all with the same character. So yes, that's pretty much it for the problem statement. Let's just get into the problem here. So basically, the optimal approach for this one is basically going to be, so there's 2 components really that are the key components to solving this problem optimally. We're going to use a sliding window, and we're also going to use a frequency map to count the frequency of the characters. So I'll say use a char frequency map, and using the frequency of the characters, we can actually, combined with the sliding window, we can actually determine the answer to this problem in linear time. So that's pretty much as good as we can do. So it's going to be linear time, and the space complexity is going to be constant, because for the data structure for our character frequency map, remember, it's only going to be uppercase English characters. So we can just use a C array where each index, we have 26 indices, and each index corresponds to one of those characters, and then we use the values to count the frequencies for each character. So let's get into the code. So for that C array, we can just say int, I'll call it map. There's going to be 26 elements there. Each one of those frequencies is going to be 0 at first, because we haven't looked at the string yet, so we can just assume that that the frequency of every character is going to be 0. We also need a left pointer that's going to point to the first index of the substring we're considering. The right pointer is going to, for our sliding window algorithm, will point to the last index of the substring we're currently considering. So left pointer, right pointer. We also need to keep track of the max frequency So basically the character that occurs the most times in the substring that we're currently looking at. We also need an integer for the result, so the longest substring. That's pretty much it for variables. So we're just going to increment the right pointer for the beginning of our sliding window algorithm. We're just going to keep incrementing it while it's less than the length of our string. That way we can go through every character in the string with that right pointer. And we can just update the right pointer by increasing it by 1 with each iteration. The first thing we're going to want to do is just update our character map to consider the character that the right pointer is pointing to basically update the frequency that that character occurs in the substring we're considering. So to do that, we need to, this isn't a normal map, so we can't just key in with any key here. We're gonna have to normalize this to be 0 indexed. So the way we do that with capital English characters, so imagine this was an A. We want the A's to correspond to 0. So by subtracting A from it, we would get 0. If we have a B here, we would get 1. If we have a C here, we get 2, etc., etc. So that's pretty much the trick for this. You just subtract A, and that normalizes the character to be 0 indexed. So we're going to increase the frequency of that character in the map, and then we're going to update our max frequency. So that's going to be the maximum of the current max frequency, and the frequency of the character that we just added to the substring. So we just access that like that. And then basically we want to think about how we're going to update our left pointer. So basically to update our left pointer, let me just write the code first and then I'll explain it. So we're going to have the substring, the length of the substring, it's going to be the difference of the length of the current substring minus the frequency of the maximum occurring character in that substring while it's greater than k. That's the number of elements we're allowed to replace. While that's the case, we're gonna shift our left pointer forward, and obviously since we're removing a character from the left side of our substring, we also need to decrease its frequency in the character map. So to do that, we can just index into our string with the left pointer and then update the frequency map like so, but we need to decrement the frequency at which that character occurs. So that's how we're updating the left pointer. And just to kind of explain a little bit more how that's working. So let's say we were considering this substring here. So our substring length is going to be 4. Our max frequency is going to be 3 because there's 3 A's there. K is going to be 1. So basically this difference basically just represents how many like different characters there are here. Like we're looking at, our goal is to try and determine like how many are the same, right? So how many are the same at most? Well, there's 3 that are the same here. Is the number of different characters greater than the amount we're allowed to replace? No. So we can try to extend that substring even more. So now we're looking at this one. Well, now there are 2 different characters here. That's going to be greater than the amount we're allowed to replace. So at that point, we would shift our left pointer. And the reason being is because basically we're looking for the longest substring consisting of the same character. And if there's too many different characters in there, we can't replace that many characters because we're constrained by k here. So we basically need to just shorten the substring and try and find a valid substring that we can replace characters in and without exceeding k. So hopefully that makes sense. After that, basically we're just going to want to update the maximum longest substring. So we can just use the built-in max function. We're going to compare it to the previous longest, and the substring at each iteration is going to be a potential valid answer just because of the way we're updating the left pointer. So we don't need any like if statements here. We can literally try and update this every time. So right minus left plus 1. And the reason why we're adding plus 1 there is because if you had, like, say we're considering this substring, this is AB, our left pointer would point to A, our right pointer would point to B, the indices would be 0, 1. 1 minus 0 is 1, but it's a substring of length 2, so we have to add 1. So that's why we're adding 1 for our substring length here and here. So after that, it's pretty much it for the algorithm. We just return longest, because at that point, that'll be the answer. So yeah, let's go ahead and run this and check out our percentages. So I'm just going to zoom out so you can see all the code. So beats 96% with runtime, 58% with memory. So it's a pretty optimal solution. There's less optimized versions of this that have like the same time complexity, but I really did try to optimize this as much as we could here. So hopefully this video helped you understand this problem more. If it did, please leave a like, subscribe, all that stuff. And I'll see you guys in the next. Peace.